The last lesson in the unit gives us another opportunity to use our volume formulas. This lesson involves putting a bunch of shapes together, like the one pictured here, and they're called composite shapes. And we can make any shapes we want. Think of an ice cream cone. An ice cream cone would be cone and a half sphere on top. And this shape here looks maybe like a lunchbox or something like that. So in finding the area of composite shapes, there are a few key ideas. The first one is to identify the shapes. So in our example to the right, we have a rectangular prism on the bottom and we have a half a cylinder on top. The other thing then, as soon as you identify the shape, is to identify the formula that you need. And finally, probably the most important thing is organization. So when everything gets messy, that's when organization is really important. So in looking at these three key ideas and identifying the shapes, that pretty much is your organization. So if I were going to look at this shape right here, I would identify we have a rectangular prism and we have a cylinder. It's a half a cylinder, but it doesn't matter. It's a cylinder. And the formula for a prism is the area of the base times the height, and the volume for a cylinder is pi r squared h. But in our cylinder formula, we only have half our cylinder, so we're going to divide that by 2. So the divided by 2 is the half cylinder. And in these two little writings, we've used all our key ideas. We've identified the shapes, we've generated our formula, identified our formula, and in actually doing that, it's already organized. So what we're simply going to do is we're going to figure out the volume of each little piece, and then we're going to add them together. And that's basically how you solve every composite shape. Some of them get really tricky, but the key ideas are the same. So in our prism then, our area, or sorry, our volume is going to equal the area of the base, and I'm going to call the base the bottom times the height. And when we get out our calculator and multiply that out, we get 728 cubic millimeters. So 3-dimension, we have a cubic unit. With our volume of our cylinder, we're going to have pi times the radius squared. So this is the one thing we have to be careful with. The diameter of the cylinder is 7, matching this dimension at the bottom. So our radius is 7 divided by 2. So our radius is 3.5 millimeters squared. And then the height of that cylinder, half cylinder, is going to be that dimension, which matches this dimension. So our height is going to be 13, and then we're going to divide by 2. And when we plug that into our calculator and round, say, to 1 decimal place, we actually get 250.0 cubic millimeters. So there's our organization. We found the volume of the little pieces, much like we did with surface area. And now we could figure out the total volume of this shape, which is 728 plus 250, 978 cubic millimeters.